Hey, happy Tuesday, everybody. Buenos martes, I believe. Okay, all right. CPM 2.3.2. Getting towards the end of chapter 2. Those problems are 2-65 through 2-68. You can see them right there. You see, got a piece of binder paper, and we're ready to go. Okay, let's get this done. See how long it takes us. I think this is going to be one of the easier ones we can get done. Okay, move that over off to the side a little bit so you can see that, and you can see my paper here, hopefully. Okay, maybe I'll zoom out a little bit. Okay, so let's get that heading. Okay, who do you want to be first? Well, one of my favorite movies of all time is very musical and I think very funny. It's called The Blues Brothers. All right, The Blues Brothers. One of the Blues Brothers is Jake Blues, the other is Elwood. And we're going to be Elwood Blues today. All right, who's your teacher? All right. Some of you are writing down Mrs. Hong is your teacher, right? And you have first period or fourth period. That's the abbreviation for period if you want to do that. Don't forget to put the date. November 3rd, 2020. And part of your heading should include the problem numbers if you're working out of the book. And we're doing 2-65. Some people like to put through. If you're only doing about 5 problems or something, maybe you just list them with commas. Okay, this would be the longer way of writing it, but definitely not confusing, right? You know exactly each problem that's getting done. Now that didn't take long. Okay, that's why we call that the easiest 3 points. Okay, all the work out of the book, we're using a rubric to grade, and you get 3 points for the heading. That's the heading. 45 seconds, boom, you have a third of the points already. Get those easy points, please. All right, 2-65, let's look at the problem. It says draw a generic rectangle to help you calculate each product. For each part, write, okay, that's a colon, the total dimension, which is the total dimension times the total dimension equals the sum of the individual area parts equals the total area. For example, on the diagram on the right, you have a 10 plus 2, so that's going to be 12, and a 20 plus 7, that's going to be 27. So you got 12 times 27. Now you notice there's nothing written in between that, but I said times. Whenever you have two numbers written next to each other or number written outside parentheses and there's no operation written in there, adding, subtracting, no addition sign, subtraction sign, multiplication sign, or division sign, what are you supposed to do? You're supposed to multiply. So this means 73 times 42. Just like the big dot, 125 times 81. Well, same thing here, 12 times 27. And what is 12 times 27? Well, they wrote out the generic rectangle. It's the same as 20 plus 70 plus 40 plus 14, and that totals 324. Okay, that's kind of what they want us to do here. So we're going to do that first with 73 times 42. When we make our generic rectangle, I usually like to have the bigger one go horizontal. Okay, and the smaller one go vertical. What does horizontal mean? Horizontal is like this. So I'm doing the 70 and then the 3. Now they put a plus sign there. You can do plus 3 if you want. Okay, don't get confused by it though. That's 10 plus 2, 20 plus 7. They're just showing you that that goes together. And sometimes they write the plus sign, sometimes they don't. Okay, so sometimes you should, sometimes you shouldn't, right? That way you don't get confused and you recognize it either way. So here what I'm doing here with the generic rectangle, 4 times 7 is 28, but I got to move the decimal over 2 spots. So fill in the egg carton, 2,800. 2 times 70 is 2 times 7, and move the decimal over one spot. Okay, 2 times 3 is easy. 4 times 3 is 12, but this is 40, so I move the decimal over one spot. Okay, now normally I'd come over here and I'd stack them one on top of another so I can get my answer, because it's easier to add or subtract if they're stacked on one top of another, right? And I get 3,066. Okay, now they wanted you to write that like this, right? As a total dimension times total dimension equals the sum of those parts. So the total is 73, right? That's how long that is that way. Whoops, let's do the parentheses. Okay, and the total dimension here is 40, and a 2 is 42. 73 times 42 equals, and then I'm saying 2,800 plus 140 plus 120 plus 6, and that equals 3,066. Now, if you're smart, and I know most of you are, and not lazy, and I know some of you aren't, right? But hey, we're all a little bit lazy sometimes. But if you're smart, it's always good to double check your work, especially on a test, and get a little extra practice. How long is this going to take us? Let's time ourselves here. All right, looking at the clock right now. How long does it take to check my work using the standard algorithm? Okay, 2 times 3 is 6. 2 times 7 is 14. Now I put a placeholder here because that's not really a 4, it's really a 40, right? 4 times 3 is 12. Carry the 1, and 4 times 7 is 28, plus that 1, 29. And now I go add, and I double checked to make sure I got the correct answer. Okay, I feel good about that now. So this is what they wanted, not just that 3066, but they wanted you to write it like this. So I'm putting my box around this for the answer, because that's the answer. And remember, a bigger box, okay, around the entire problem. Then I go do the next one. Okay, same idea here. We're doing 125 times 81, 3 digits now. Okay, now I'm going to set this up for you, but you're going to finish. Okay, what am I writing on the top for that 125? Well, each digit gets its own part of the box. So that 1 is 100. The 8 is, or the 2 is 20, and the 5 is 5. And you can put the plus signs if you want. Here I have the 80 and a 1. The 8 is 80 and 1. So I'm going to multiply this and get these 6 numbers. It's going to be a long sort of problem here, right? Because I'm going to be adding 6 when I get done. 125 times 81 equals, and I'm going to do the first part for you, 8 times 1 is 8, and I move the decimal over 3 spots. So the first add-end is what they call it, it's a product too, but over here in the problem, since I'm adding it, it's an add-end. So is 8,000. You're going to get the other 5 boxes, put that, and do me a favor, go ahead and double check your work using the standard algorithm. Okay? Okay, 2-66. Copy and complete the table of multiples below. 3s and 4s. 3, 6, 9, 12. Okay? I used to like watching something called Scholastic Rock, and it was sort of something from the 70s. And I have one that's called Multiplication Rock. And there's a song for the 3s I used to like. 3 is a magic number. You should Google it. It's probably watching on YouTube or something. Okay, so the 3s and the 4s, and it says to complete them. Okay, and we have 3 and 4, and 3 times 2, 4 times 2, 3 times 3, 4 times 3, and so on, right? 12. and they said extend it out so it has 14 columns and values. Wow, we got pretty far here. I'm not sure if I wrote enough space, right? 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to go 11. You're going to have to finish and do it right, okay? I made the mistake for you. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. The ones that you can't see here are going to be 36, 39, and 42. And for here, I have 16, 20, 24, 28, 32, 36, 40, 44. And what's missing on the fours is going to be 48, 52, and 56. Now, A, write down all the numbers that appear in both rows. So I'm looking for numbers that appear in this row and this row, okay? And when I go over here, 6, 9, 12, okay? So I have a 12, okay? And then are there any more? 24, okay? Are there any more? You're going to find out, okay? So I got you started. I got to tell you, there's at least one more. And B, what is the smallest multiple of both 3 and 4? Well, that answer has already been identified for you. So I'm going to have you find that one yourself, please. Okay. And then C, write more numbers that are multiples of both 3 and 4. So I think they want you to find some that aren't on this chart. Okay. And I'll give you a hint. 12, 24. Yeah, that's your hint. That's all you get. Okay. Jenny is saving for her babysitting money. Now remember, if you get a second page of homework, you need to write your first and last name down again. You don't need the entire heading again, but please write your first and last name. It takes all of about 5 seconds. Capitalize your names, please. All right. Jenny has been saving babysitting money for a field trip to Washington, D.C. Okay. She wants to save $200 over 3 months, and she saved $53 the first month and $67 the second month. Okay, so sometimes it's good to just read the entire problem without writing anything and then go back and say, okay, what are they asking? And then read it knowing what they're asking. Okay, so it's going to, I know it's going to be important that she needs $200. Okay, I know it'll be important that so far she has saved 53 the first month and 67 the second month. Now, since none of these numbers have any cents to go with them, I'm not going to put 0.00, right? Now, if they had cents in one of them, I'd have to put the cents in all of them. But since there's not, I'm just writing 253 and 67. Okay, question. Estimate without calculating the amount of money that Jenny needs to earn during the third month to get her goal. Well, she needs 200. She has about 50 and about 70, right? This is about, and 50 and 70 together is 120. I can do that one in my head. So 120 plus what is 200? Well, I think you know that. So A is you got to estimate. Okay, you're going to finish that. And B, now show how Jenny could calculate the amount she needs. Okay, and we kind of did that with our estimate. Okay, you're going to add these two, get your total, and subtract it from 200. And that'll get the exact answer for B. Okay, you can do that now. Okay. 2-68, find 3 fractions that are equivalent to 3/8. Equivalent, that means they equal 3/8. Well, I'm going to give you a hint on this. Sometimes drawing a picture helps. Let's draw a picture, and let's divide this whole into eighths. Okay, so that shaded part is 3/8. Okay, and this is one way of doing this. Okay, find three fractions that equal that. Now that's 3/8. Okay, pretend that's a big old birthday cake or something, and you decide to cut it into smaller pieces. So you're going to put a cut here and a cut here. Now, instead of having eighths, how many pieces do I have? 4, 4, 4, 4. I have 16. And those pieces, instead of 3/8, I have 1, 2, 3, 4, 5, 6. I have 6 16ths. It's still the same amount of the cake, right? So it's equal to 3/8, but it's a different fraction. Okay? Another way of doing it. Let's divide it again. You have a lot of people and everybody's on a diet. They don't want big pieces. So you're cutting them up again, all of those pieces in half. Now I have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. I have 32 little pieces, and I didn't cut any more out of here. But how many little pieces, how many 30 seconds do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 30 seconds might be equivalent to that. I'm going to have you use that. There's also something called the magic one that I'll do a little video about tomorrow. Might put it in a warm-up video too for you to help you out. So you can use the magic one. Watch my warm-up video, okay, for Tuesday if you want some help on that, okay, to use the magic one. Last one, 269. Okay, you're looking for 3 there. Janelle and 3 of her friends bought 4 smoothies. They bought 4, right? Her and 3 friends. That's a total of 4. It makes sense. Everybody gets 1. For a total of $3. If she purchased smoothies on another day for herself and 9 of her friends, how much money will she spend? Okay, so now how many friends and how many total smoothies is she buying the next time? 10. So $3 was the price for 4 smoothies. Like wicked slush, huh? How much would her and 9 friends? Now, what do we have to do? We have to figure out how much each smoothie is. If 4 smoothies comes to $3, how much was each smoothie? That is the kicker. That's the hard part, okay? Figure it out. Here's a hint. If 4 smoothies is 3, how much would 2 smoothies be? It would be half of 3, huh? How do you get half of 3? Well, half of $3 is how much? You're splitting $3 with your best friend? Figure that out. I'm going to tell you it is $1.50. So if $1.50 is the cost of 2 smoothies, how much is each smoothie? And then apply that there, okay? I think that's enough of a hint for you to get it done. If not, if you're still stuck, please come to one of your afternoon Zooms for your teachers. We're lonely at 2:30. We're lonely in the afternoon. Come see us, visit us, ask us a question, because that's like giving us cookies, right? All right. Good luck, everybody.